Okay, so this is the last set of problems on the back page of that last packet. So this is the back page of that last packet. These are what I would call the triangle problems, because we're going to have to draw triangles to do it. But we've been drawing triangles since the very first day. So once again, we're going to give you the identities so you don't have to flip out about it. So we go to a situation like, I'm given sine x is -5/4, cosecant x is less than 0, cotan y -12/5, sine y is less than 0. And I want to find the sine of x plus y. Here's my x, here's my y. Cosine x minus y, tan x plus y. So I'm going to have to use these identities. But we've done this before. Oh man, I got to draw a triangle. So you're going to say to yourself, secant is negative, cosecant's negative. Where does that happen? Well, that only happens in the fourth quadrant. I'm sorry, I'm at third quadrant. See, I was drawing it in the third quadrant. That only happens in the third quadrant if they're both negative. So let me see, secant 5, so that'd be -4. So my missing side is -3. So there's my x triangle. Then over here, you'd say, cotan is negative, sine is negative. Where does that happen? Cotan's negative, sine is negative. Oh, the only place that happens is fourth quadrant. So this one is fourth quadrant. So here's my y triangle. And you're saying, let me see, cotan would be adjacent over opposite. So fourth quadrant, the y is negative. Pythagorean triple. So that's going to be a 13. Well, how convenient. At least they're Pythagorean triples. Okay. So here's what they're asking us for. They're asking us for sine of x plus y. So you just have to say, oh, sine of x plus y. And we're going to give you the identity. So here's my identity. So sine of x cosine y plus sine of y cosine x. And then we just go look at our triangles. Oh, here's triangle x. What's the sine of triangle x? Oh, -3/5. -3/5 times. What's the cosine of triangle y? Triangle y, let me see, cosine, adjacent over hypotenuse, so 12/13. Big plus sign, sine of triangle y. Well, the sine of triangle y, -5/13. -5/13. Cosine of x, so if I look at x, well, that's -4/5. Now we just clean this up. And one thing that happens every year when you're doing these problems, the hypotenuse needs to be the same. Hypotenuse needs, not hypotenuse, what am I saying? The denominator. Because you're doing this, the denominator should be the same. So what do we get here? -36 plus +20. So -16/65. So it's really not that big of a deal. We're giving you the formula. You just got to set up the triangles, which, may bother some people, but it still works out nice and neat. Now, just for the record, if the problem had originally been find the cosecant of x plus y, you'd say, there's no formula for cosecant. But cosecant's just the reciprocal of sine. So the cosecant, you just flip that sign over. The end. See, that's not a big deal. Okay, so let's do the cosine of x minus y. So over here we say, okay, so I got to do the cosine of x minus y. So here we go, cosine x, cosine y plus sine x, sine y. So once again, cosine of x, that's no big deal, -4/5. I got my nice triangle. Cosine of y, 12/13, no big deal. I've got my nice triangle. Plus sine of x, -3/5, sine of y, -5/13. So what do we get here? -48/65 plus 15/65. I hope I'm doing that right. So, okay, once again, common denominator, how easy, no big deal. So that's -33/65. So there's your cosine. And once again, if somebody had said, well, we want to know the cosine I'm sorry, we want to know the secant of x minus y. We just say, well, duh, that's just the reciprocal of cosine. So we just do the cosine and flip it over. Doesn't have to be anything fancy. We don't need a formula for secant or cosecant. Okay, now the tangent, unfortunately, is a little bit more annoying. So tangent x plus y. So I'm supposed to find tan x plus y. And the only thing that makes it more annoying is we have these fractions. So tangent x plus tangent y over 1 minus tan x tan y. So it's just the fractions that make it more annoying. So I look at my triangles and I say, all right, x, tangent of x is -3 over -4, better known as 3/4, plus tangent of y, -5 over 12, so -5/12. So yep, I got fractions that are going to hurt my feelings. So 1 minus 3/4 times -5/12. So yeah, this is going to be a pain. So if I think about it though, let me see. If I multiply, is anything going to, oh, we're going to get some simplifying. I don't know. There's so many different ways to approach this. I hate to start doing too much cleaning. Because we could simplify, and that's going to make a 4. Then we're going to get 16. I don't know. I'm just going to go with the 48. I'm going to go with the 48 and then simplify it later. Because right here, we get 1. Check it out. Minus minus is going to make plus. So that's going to be 48 and 15. So this guy here, so what is that going to be? 36 and -15? No, 4, -20. Okay. So I know, a little bit of a hassle, but it's fractions. We know that. It's going to be that way. So what do we have here? 16 over 48 over, okay, I'm going to write this step, even though you probably don't need to. 48, the 1 is 48 over 48 plus 15 over 48. So I have 16 over 48. What is that, 63? Okay. Now, as we've been knowing since we were little kids, now we can multiply by the reciprocal of the denominator, and how convenient, the 48s cancel and leave me with 16 over 63. Okay, so it's a little bit more of a hassle since you had to deal with these fractions like this. And like I didn't try to simplify here like the 3 and the 12, because it ended up being the 48s were what I needed all along. So I just went with the easiest common denominator by multiplying. Just for the record, one more time, if somebody said, well, I wanted to know what the cotan of x plus y was. Well, there's no cotan formula that we're given, but you say, oh yeah, duh, that's just the reciprocal of the tangent. So these guys are definitely a little bit more labor intensive. Okay, a little bit more labor intensive, but it's not that big of a deal. We love drawing triangles. Been doing it since the first day. We're giving you the identities and we just plug and chug and clean them up. Okay, not that big of a deal. And the back page, the very, very last page of the packets we're giving you are problems like this, and they're all nice Pythagorean triples.